Welcome to this module on the fundamentals of electronic data capture, or EDC. In this session, we'll explore key features and functions that you should consider when selecting an EDC system for your research. Whether you are capturing patient data, survey responses, or experimental results, these concepts are crucial for ensuring that your data is collected, stored, and managed securely and efficiently. We'll focus on an EDC platform that exemplifies many of these core principles. This platform is widely used in research settings because of its user-friendly design, powerful features, and ability to adapt to a wide range of research projects. While we will use this particular platform for demonstration purposes, the lessons learned here can be applied to any clinical or research data collection tool. The goal is to give you a solid foundation in EDC, helping you make informed decisions when evaluating or selecting a platform for your own research needs. Overview of electronic data capture systems. EDC systems are critical for modern research, especially as studies grow larger and more complex. In the past, data collection often involved manual processes or tools like spreadsheets, which were not designed for secure or efficient research management. As a result, researchers frequently faced issues like data breaches, inconsistent data entry, and poor audit trails. An effective EDC system must address these challenges by providing a secure, organized way to collect, store, and manage data. Key features of a robust EDC system include data security, ensuring that sensitive data is protected against unauthorized access. Audit trails, tracking who entered or modified data and when those changes occurred. Customization, adapting the system to meet the unique needs of different research projects. And usability, ensuring that data entry is straightforward and user-friendly, even for non-technical. While the platform will focus on an example of one such system, these principles apply broadly across EDC tools used in clinical trials, scientific research, and other data-driven disciplines. Key features to look for in an EDC system. User interface and project data. Log into an EDC system, you should have immediate access to an overview of all your active projects. This dashboard should allow you to see key metrics such as the number of records or data entries collected, the current status of each project, whether it's live, in development, or archived, and the specific permissions and roles associated with your account. For instance, while an EDC platform might host hundreds or even thousands of projects, you should only be able to access the ones relevant to your work. This means that user permissions must be clearly defined, ensuring that each team member sees only the data they are authorized to view. Data collection forms, often referred to as case report forms, CRFs, or data instruments, are the heart of any EDC system. These forms allow researchers to capture the data relevant to their study. It's essential that these forms be customizable, tailored to the specific data needs of each project, whether it's a clinical trial, observational study, or experimental research. They should be human-readable, designed with clear, simple language that is easy for users to understand and complete, rather than using technical database terms. Validating data is also crucial. Data entry fields should have built-in validation to ensure that users input the correct data types, like numbers in numerical fields or dates in fields. If an incorrect entry is made, the system should prompt the user to correct it. Additionally, consider whether the system allows for branching logic. This means that the questions asked will vary depending on previous users. For example, if a user selects male in a gender field, the system might not show questions related to pregnancy, ensuring that irrelevant or invalid data isn't collected. Maintaining data quality is one of the biggest challenges in research data management. An effective EDC system should include data validation rules. These rules ensure that entered data adheres to predefined formats, ranges, and categories. For example, if you're collecting age, the system can limit entries to numbers between 18 and 100, preventing out-of-range or erroneous values. Drop-down menus and predefined options are also important. To avoid inconsistencies, categorical questions like gender or status should be presented with fixed options, eliminating the possibility of varying responses. Additionally, data checks for completeness can flag incomplete forms or missing fields, ensuring that important data isn't overlooked. Every EDC system should maintain a detailed audit trail, which logs all interactions with the system. This includes identifying the user responsible for data entry or modification, documenting the nature of each change, like data entry, edits, or deletions, and recording timestamps for every action. Audit trails are essential for ensuring data integrity and compliance with regulatory requirements. They also help identify potential errors or inconsistencies in data entry, making it easier to troubleshoot issues during or after data collection. Data export and reporting. After collecting data, the ability to export it into useful formats for analysis is crucial. A good EDC system should allow you to export data into commonly used formats, such as CSV, Excel, or statistical software formats like SPSS or SAS, without unnecessary complications. Additionally, the system should support de-identification for confidentiality purposes. For example, if you need to share data with external collaborators or submit it to a regulatory body, the system should offer tools to anonymize or obscure sensitive information, such as shifting dates or replacing personal identifiers with codes. PDF generation and offline use. While most data entry and management happens within the system, it's often useful to have the ability to generate PDF versions of data collection form. This can be especially helpful in the following scenarios. Ethics review. When submitting a study for institutional review board or ethics committee approval, you may be asked to provide a clear outline of your data collection instruments. Contingency plans. In case of system downtime or connectivity issues, for example, during field data collection, having offline copies of forms ensures you can continue to collect data without disruption. These PDFs can be filled out manually and later entered into the system when access is restored. Integration with other tools. As research grows more complex, an EDC system should integrate smoothly with other tools and platforms. For example, data captured in the EDC system might need to be analyzed using statistical software or combined with data from other sources. Integration with tools like laboratory information management systems, electronic health records, or statistical analysis packages should be seamless and straightforward. In summary, when selecting an EDC system for your research, it is crucial to look for a tool that provides strong security features, a user-friendly interface data validation capabilities, and flexible options for exporting and reporting. The system should adapt to the unique needs of your project and ensure that data collection is both accurate and efficient. In the next section of this course, we'll dive deeper into the practicalities of using an EDC system for real-world projects. You'll learn how to navigate the system, set up data collection forms, and ensure that your research adheres to best practices in data management. By the end of this module, you should be well equipped to evaluate and select an EDC system that meets the needs of your research team and helps ensure the success of your projects.